Good afternoon, everyone. My name is Bear Church. I'm the project manager as well as one of the structural engineers for Hayman Engineering. With me today, we have Jack Larson, our environmental engineer, Leah Hammond, our transportation engineer, and Alex Ketter, our other structural engineer. So just a quick overview of the Amazon industrial site project. We were tasked with the design of a new academic building along with the parking lot associated for that. We are also tasked with the design of a new connector road connecting County Road 17 to County Road 19, and this will provide access to our building as well as connect the two county roads. And lastly, we were tasked with the design of a water treatment system which will provide clean water to our building as well as the surrounding areas. So like I said, I'm also one of the structural engineers on this project. With that comes certain responsibilities. My task was to design a new academic building with around 30,000 square feet of area. This to include classrooms, labs, offices, an auditorium, and a covered outdoor space. And all this will be done in accordance with the necessary codes and regulations. So the ASCE 7-16 code, Elkhart County Building Code, the International Building Code, as well as any other relevant material codes, such as the ACI code for concrete and so forth. And then lastly, I have to develop and evaluate 3 different alternatives. So just to recap from the last presentation, my first alternative is a 2-story reinforced concrete building with around 31,000 square feet of area. The one thing I want to point out with this alternative is that the auditorium is a double height auditorium, meaning that it is 2 stories tall, but there's only going to be 1 floor. And this will be around 4,000 square feet of area. And to the right of my floor plan, you have my proposed beam and column layout. Like I said, it's proposed, so it is subject to change in the design phase. And lastly, my cost was estimated to be around $7.5 million, and this was estimated using RS means. So alternative 2 is the exact same as alternative 1, the main difference being it is a structural steel building instead of a reinforced concrete building. That being said, the cost is around $6.5 million, and this was estimated using RS means as well. So alternative 3, it's a little bit different than the first 2 alternatives in the fact that the layout varies. It's a little bit bigger. It has roughly 32,000 square feet. It's a 2-story steel structure. As you can see, the courtyard in the center will act as the covered outdoor space, and the auditorium is a little bit smaller. In this alternative, it's around 3,600 square feet as opposed to 4,000, and again, it will be a double height auditorium. And as you can see, the layout is a little bit more complex than the first 2 alternatives. That's just something I want to note right now. And then lastly, the cost was determined to be $6.8 million for this alternative. So here's my evaluation rubric. It considers multiple parameters such as construction costs, feasibility, aesthetics, environmental impacts, and space efficiency. And these are all weighted on a scale of 1 to 5, with 5 being the most important and 1 being the least important. I also have a rating scale of 1 to 5, again, with 5 being excellent and 1 being not so good. And how this evaluation rubric works is it kind of pits the alternatives up against each other. So it's not necessarily about the market cost. If the alternatives are significantly higher than what market cost would be, it's rather if alternative 1 has a higher construction cost than alternative 2, then alternative 2 is going to receive a higher score in that category. So here we have the selection of my alternative. Alternative 1 received a weighted score of 50 out of 75. Alternative 2 received a weighted score of 65 out of 75. And alternative 3 received a weighted score of 50 out of 75. So obviously I chose alternative 2. And the reasons for this include it was the least expensive alternative compared to alternative 3 and alternative 1. It also was more feasible and less complex than alternative 3 just because of the layout and the design. And then the space efficiency was also utilized better than alternative 3. And now I'm passing it off to Jack.
Well, as I said, I am in charge of the environmental scope where I'm designing a water treatment plant that is planned to treat approximately 1 million gallons of water per day. So far, in my work completed, I've done the site evaluations, created the preliminary designs, gone through the alternatives, groundwater, surface water, and river water, done the designs on AutoCAD, created a cost analysis for each of them, and had my final alternative selected based on my analysis of each system. First off, we have groundwater. As you can see right here, it is a water pump, there'll be a water pump that will be on site, reaching about 300 feet in depth below the surface. As you see right here, the water level is about 50 feet below the surface. Calculated with with 2 pumps on site, with the materials needed for creating the piping, going through the process which we'll need to purchase the treatment systems, filtration, disinfection, as well as calculating the price of the storage tanks, come to a total of about $4.5 million for the first alternative. Second, we have surface water, as you can see, with it being taken from the Heaton Lake nearby, about 6,000 feet away, with which I'll need to construct a pipe for. See right here, we have the different sieves that will filter out any large hazards in there. Filtering it, bringing it through here, as you can see, a pump that will transport the water through there. Calculating each of the costs, it'll bring us to a $5.5 million cost. Last but not least, we have the river water, with which there will be an underwater pump that will siphon in water from the St. Joseph River, bringing us to a cost of around $6.3 million. As well as here, we have a design for the water storage system, which there will be two composite water tanks on site made of stainless steel, each designed to house about 750,000 gallons each. My evaluation rubric, I had organized it based on the cost, the feasibility, the complexity of the design, the water quality of the source I'll be using, and the overall project impact. Basically meaning just how much will this affect the surrounding area. Will it be invasive? Will it be distracting? How much work is going to need to be put into designing each of them? With going through them, my scoring alternatives, I determined that compared to the average, the cost of alternative 1 would have been more cost effective compared to the other 2. Going down, it's a lot more feasible to be creating a water pump on site compared to having to create thousands of miles of piping in order to bring water towards the source from farther away. With it being not too complex overall, and water quality as designed, there will be chances of some contaminants in the groundwater due to the stagnation, but that will be filtered out likely due to the filters I've set in. The overall project impact would just be fair with the first alternative. As for the second alternative, it is about above average price of about the 3 of them, of around $5 million. With feasibility, as said for the other 2, being a long piping, which would be very expensive and very impractical, as well as with calculating in the maintenance costs that would be required. Going down the list, I've decided that groundwater would be the best alternative going forward with this. And I will be handing it over to Leah.
Thank you, Jack. So moving into the transportation scope, I'm going to do a quick little recap before getting into my alternative analysis. So the transportation scope included extending County Road 4 to connect County Roads 17 and 19 while providing access to the school building that will be designed, as well as designing a parking lot for that school and designing a signalized intersection where County Road 4 extension will meet with the toll road, and design a stop-controlled intersection where County Road 4's extension meets County Road 19. All design controls were following in the unit design manual, the Ashton Green Book, and any Elkhart County regulations. So for the scope, we were also given an intersection design due to a previous traffic study, which included 2 left turn lanes and 1 right turn lane heading northbound, a left turn lane and a through lane heading westbound, and a through and right turn lane and additional right turn lane heading eastbound. As well as on the County Road 4, County Road 19 stop controlled intersection, no work will be done to County Road 19 as existing infrastructure will be maintained, but there will be a designated left and right turn lane with a stopping for County Road 19 traffic. Road 4 and the school road entrance. This design will be subject to change per the alternative chosen. So a big part of evaluating my alternatives was determining a cost estimate. This was using the INDOT unit price summaries with using the Indiana design manual to determine a travel lane being 12 feet, an uncurved shoulder being 8 feet, an auxiliary lane being 12 feet, and then ditch width for slope and back slope, which will be used for further design next semester. Additionally, I decided to use asphalt for my design as was able to get a structural number with aggregate depth of 8 inches, a base asphalt depth of 4 inches, and a surface depth of 2 inches. As the ideal structural number for school zones is between 3 and 4. So my alternative one is a 3-way signalized intersection, kind of tying into the existing toll road, and has 2 entry and exit points into the school. The cost for this alternative was estimated to be about $1.5 million. Alternative 2 ties into the existing toll road, not adjusting its layout much at all, and would have a 4-way stop or signalized intersection, and has 1 entrance into the school parking lot. And my third alternative is similar to my first alternative, but the entrance to the school is much closer to the parking lot, shortening the distance between the connecting road and the parking lot. So, using my evaluation rubric, I determined the key parameters being cost, space required, traffic flow, pedestrian safety, and environmental impact, weighting these as the impact and cost being the highest ones, as we don't want to go into the wetlands and floodplains, and then rating these on a scale of 1 to 5, 4 being 1 and excellent being 5. So I determined that design alternative 3, with the shortening of the road connecting the school parking lot, and connector road 4 being the best alternative for this project. And then, once again, there's 2 entrances and exits, and it's a 3-way signalized intersection instead of a 4-way. It had the best traffic flow during peak times. I was not able to analyze that because I do not have specific numbers, but just kind of visualizing it with there being 2 entrances and 2 exits, it would have better traffic flow during drop-off and pickup times. Additionally, once again, the estimated cost for this one was about $1.5 million. Now moving into my parking alternatives, my parking alternative 1 has 90-degree parking, has 60 stalls, 3 being ADA accessible and 1 being ADA van accessible. This allows for 2-way traffic and has 2 entrances and exits. The estimated cost for this was $200,000. And then my parking alternative 2 has 45-degree angle parking. It has 2 compact spaces, 3 ADA spaces, and 1 ADA van accessible space. This allows for 1-way traffic and also has 2 entrances and exits. So my evaluation for this one was similar, but I did not include the wetland impacts because where I was placing the parking lot was not within a wetland. And then also I switched around traffic flow and pedestrian safety due to there being a lower speed limit within a parking lot. I prioritized traffic flow over pedestrian safety. So with this one, parking alternative 1 was my chosen alternative. And this is because it has greater room for vehicle maneuvering, it requires less space, it had a lower cost, and the pedestrian safety and traffic flow were comparable between each alternative. So moving on, I'm going to pass the torch to the structural person, Alex.
Thank you, Leo. Moving on to the structural scope, so as I did in my progress presentation, we have our project objective, which was to make an academic building, which is around 30,000 square feet. It includes an auditorium, a covered outdoor area, labs, offices, and classrooms. All this will be done in compliance with codes such as ASC 7-16, Indiana regulations with Elkhart County, and international building codes and any other codes that would be needed to design the building. It also includes 3 design alternatives. So the work completed so far, just like in the progress presentation, I've done a site analysis in compliance with my team to decide where the building should be on the site. Also, load determination and code compliance kind of go together, determining live dead loads depending on which material we want to use. For the design alternatives, I have floor plans for first and second floor. This will be a 2-story building. Material selection and research, just researching which 3 materials I wanted to use for my 3 alternatives. And then beam, column, and girder layouts, it will all be the same for each alternative. And then my alternative that I ended up selecting. So the same as the project presentation. Again, we have our first story plan and second story plan. On the far right, we have the auditorium, which will be 1 large room, and it'll only be, that. And then a covered outdoor space on the left, and in between we have our labs, classrooms, and office area. Moving on to the right side, we have the alternatives, so I decided to do 3 alternative materials for the same building design. And for reinforced concrete, all of the estimated costs were construction costs using the RS means data, and I got 8.7 million for reinforced concrete, for steel, 7.4 million, and for timber, 7.2. Moving on to the column beam girder layout, so all this will be the same. On the far right, we have our auditorium. The thing for the auditorium will be that there will be a truss design to help support it rather than just beams and girders, so there will be no columns in the middle of the auditorium. On the left, we have our covered outdoor space, just some beams. And then as color-coded, girders are blue and columns are little green dots that are spaced out at 23 feet and 27 horizontally. And then beams are covering the other spaces. For my evaluation rubric, I took into 5 key parameters, which includes construction cost, feasibility, aesthetics, environmental impacts, and space efficiency. All of this is on a weighted scale and is rated from poor being 1 and excellent being 5. Moving on to deciding which alternative I wanted to go forward with. We have the same parameters and a weighted scale. It ended up that alternative 2 was the best one to move forward with, so I selected alternative 2, which will be a 2-story steel structure with 32,000 square feet, 570 feet as a perimeter, and using the RS means estimated construction cost is just below $7.4 million. Just to further the point home of alternative 2, not just those reasons, the cost efficiency and the speed of construction. Steel is not the least expensive one, but it is very efficient in constructing it because you can create some of the materials off-site and move them onto site to help speed up the construction. There's also a high strength to weight ratio of steel as compared to other materials, and the durability. Steel is much more durable than other materials that were considered, and a long lifespan, which leads to less maintenance when checking on things in the future. Now we'll be passing it off to Barrett for the cost. So this is our phase 2 design cost estimate. So this is for next semester. I included myself in here, so that will have to be removed next semester as I will not be here. But just the disciplines, we split it up by discipline. So project manager, 2 structural engineers, an environmental engineer, and a transportation engineer. And our hourly rate included overhead and profit. And our total cost rounded out to be around $60,000. Here is our construction cost estimate. This has a similar format to our phase 2 design cost estimate. The one thing to note is that the structural portion will be using Alex's just because I will not be here next semester. The total cost for the construction is around $13.5 million. Add in 10% contingency, and that turns out to be around $15 million. Any questions?
Maybe we start with you, Barrett. I want to ask you the same questions I asked Abby in here about your cost estimate and about.
I think I where you're going with this.
So,
Are you talking about this figure
yeah,
right
look
here?
at these numbers, and actually it seems to be like a trend in here. Actually, I think the record is with Jack now, he got to 0.44 in there, so pennies, and since this is a schematic level, preliminary type of design, the expectation that you guys can be close maybe to 10,000 or maybe even 20,000, so don't expect anything to be near even a $500 or $1,000 in general. So I'll leave it there.
Well, the reason I did it this way is just because I wanted to give you more specifics on at least my individual alternative. At the end is when we rounded for the total construction cost, so I think that's kind of why we did it that way. As you can see, no 500s, no cents or anything like that. Pretty perfect.
You actually made a very good statement I like about the environmental impact, which is the second. Now, you said this is this is relative in there. But did you consider, because again, I'm reflecting back on what was presented, she said, this is the carbon footprint in there. Did you guys use any sort of calculator, because they do exist, to say for the different types of materials, and then this is where I'm gonna pick on Alex, because he gave you can still give me the answer. He gave the same score, like a 3 for all 3 different alternatives for the environmental impact. So though he's using wood, steel, and concrete, why is this? Don't you think there will be a different environmental impact? Alex, you can answer, then I will go back to Barrett.
Yeah, so I mean, when we're evaluating, kind of what it says in there that they're kind of not close, but they're kind of the same, if that makes sense, and there's not a super high on one side and high on the other, so that's why I chose 3 for most of them, but,
So why is it a criterion to start with, if it comes back to be the same score for all alternatives?
yeah, I mean, I guess preliminary, it was one of the 5 things that we wanted to go forth with all of our group. I feel like we all use kind of the same 5 key parameters, so I guess that's kind of why I followed through.
I'll accept the answer. And, I guess I'll pass the cost and environmental impact. Jack, you presented the different sources, like 3 different sources, the lake, the river, and the groundwater.
Yes.
How about the treatment?
The treatment plant, the treatment process, I had included the different treatment budgets in each of the alternatives, because some would require less than, some would require less.
What are the treatment
Okay,
techniques
so-
or processes?
So for treatment filtration, we would be using I'd be using sand filters and activated carbon for filtering it out. And then for disinfection, I would be using pH correction and carbon absorption.
And for surface water?
And for surface water, I'd be using coagulation, flocculation tanks, very simple sedimentation, and then for filtration and disinfection, I decided to use the same process that will be used in groundwater
Did
treatment.
you do preliminary schematic level calculations to figure out what are the required sizes or the estimated sizes?
I've done estimated sizes. These were not included in this presentation, but they were included in my calculations.
Okay, thank you. Leah, I want to ask you a question, it's for my knowledge. What is a minimum length of an acceleration lane?
So a minimum length of an acceleration lane it varies based off of the design speed that you are at. For this one, it's 45 miles per hour. So coming off of from a stop, the acceleration lane is going to be larger. So I would say for this one, I have not calculated it yet, but I would say, I know the taper length has to be 100 feet, but beyond that, I would have to do some calculations.
Thank you,
to figure
that's
out
good, that's
the-
all what I need. Yeah, I mean, that's it. Thank you.
I encourage all of the transportation folks, but especially you, Leah,
Yeah.
because this is a school zone,
Mhm.
the pavement marking and the signing and all that stuff is gonna be a little more complex than, here's a stop sign.
Yeah, so, I did account for pavement markings in my cost estimate. And I did, with the 10% contingency, most of that will be going to school zone regulations. That'll be accounted for in our cost.
I have no questions.
Oh,
Barrett, I have two things for you to clarify. First off, will you or will you not be here next semester?
I can neither confirm nor deny.
Second thing, what color is your suit?
This